All right, SN1 reactions. Couple things about it. SN1 means substitution nucleophilic unimolecular. Substitution because we're changing the leaving group with our nucleophile, the nucleophilic. And the unimolecular has to do with the speed of the reaction. It only depends on the electrophile or the leaving group. This is because the nucleophile can't even attack until the carbocation is formed. So again, this reaction depends on carbocation stability, so it's only going to be an SN1 reaction if there's a good carbocation available. You also produce a racemic mixture, which we'll get to in a second. First thing that happens is the two electrons in this bond here go onto the bromine. That's going to produce this bromine anion and a carbocation. You know why it's stable. Hopefully it's tertiary, tri-substituted with alkyl groups, or maybe even resonance stabilized. So the first step is pretty slow. That's the unimolecular part. The substitution is when the nucleophile comes in, starts at the minus, goes to the plus. It can go to either side of this carbocation because what's really here is this empty p orbital that we're donating electrons into. And because they get attacked through the top or through the bottom approach, it's what produces a racemic or a 50-50 enantiomeric mixture. I just drew an achiral compound, so it's not going to matter. But if it is chiral, be aware that you can get a 50-50 mixture of R or S. There are some questions in the description. There's a link to a Google Drive where you could do some example questions and test your answers.